Okay, so the other thing is just classifying numbers. Now, numbers come in lots of different flavors. There's these things called natural numbers, whole numbers, integers, rational numbers, and irrational numbers. So they're all real, okay? The idea of a real number is that if you could say it, think it, or write it, it exists. It's real. Real numbers split into two groups. There's irrationals, and then there's rationals. So if you can kind of see, I took this out of the book. Rationals is kind of this whole group right here. And then inside that group, there's an even more defined group, and then inside that, and inside that, okay? So the biggest thing is that irrationals are, well, irrational. What do you mean? They're very ugly decimals. All of these, if you cannot write it nice, or if the decimal is just really, really gross, it's an irrational number. That's why it's called irrational. There's really no rational way to write it down. So all of these would make really, really weird, disgusting decimals, okay? So to be rational means you either have nice decimals or you can at least be written as a fraction. Like you're like, oh, that's repeating. Yeah, but that's, I think that's 3/9. Yeah, that's 3/9, which is actually 1/3. Wow, good job, math teacher. See, that's pretty. Look at that. 1/3 is actually pretty rational. It's not that bad. These ones, none of these can be nice fractions. Okay, so I think that's the actual real definition of a rational. Could it write like a fraction? Yes, it could. Okay. Now what about this one? This one looks like it's kind of scary. Well, let's double check. Okay. Square root 0.25. Oh, that's just a half. Okay. See, that's pretty rational. It could be in disguise. It could look irrational, but it's not that bad. Oh, negative 2/3. Yeah, that's rational. It's a fraction. Okay. Basically, can you write it as a nice fraction? Yes or no? Yes, it's rational. No, it's irrational. I think that's the actual real smart math teacher way to say it, is that can you write it as a fraction? No. Yes. All of these could be written as a fraction. So this is kind of like the short way to describe it. Not shortcut, but the real world way to describe it. Integers are positive and negative numbers without decimals. I think of them as the temperature numbers. These are the numbers that the weatherman will use. There's not really any decimals. So positive and negative temperature numbers, they can use positives, they can use negatives. They just don't want to have any decimals. So I should probably add that in there too. Okay. Decimals are for just rational numbers. Integers, no decimals allowed. Now again, what do you mean? This can't be an integer. Yeah, but when it simplifies, I think that'd be -2. There you go. This would be -4, -3. Look, temperature numbers. Whole numbers are basically no decimals and no negatives. Oh, I should write that down. No negatives, I forgot. Whole items. Whole numbers would be like when you're counting the number of people. Okay, no decimals, and you can't really have negative people. Okay, temperature, yeah, you can have negative temperatures, but number of people, number of actual physical things, you can't really have negative things, physical things. So think of it that way. So think when we're talking about people. Okay, and then honestly, whole numbers, natural numbers, the only difference is that you can't have the number 0 in natural numbers. And I don't know why they're splitting hairs. That's the only difference. It's the exact same as whole numbers. You just can't use 0. Maybe it's because 0 is an invention of man. Does that sound like if you think about an animal looking in the forest, they're not going to think, oh, look, there's 0 trees over there. They're just going to think, oh, there's no trees. I mean, honestly, I don't know how else to explain that. That's the only difference between natural numbers and whole numbers. Probably made a lot of really, really smart math people mad at me for saying that, but hey, that's how I understand it. That's the best way for me to explain it. All right, so let's classify some numbers. Problem number 3 on page 18. What do we got to do here? Oh, there it is. So I'm going back to the, going back to the book here. Here's page number 18. Problem number 3 on page 18. Okay, we're going to classify them. So 15 is basically all of them. Okay, it's a natural number, it's a whole number, it's an integer, it's a rational. I like to abbreviate. It's rational because it ends, it's terminating. You could write this as a fraction. This isn't that crazy of a decimal, so at least it's rational, but it has a decimal, so you stop at rational. So, hey, look at this thing right out of the book. I stole it. Okay. Irrational. If you do the square root of 57, it's going to be disgusting. Okay. Square root of 9. That turns into the number 3. Okay, so that's all the flavors of this one. So it's a natural number. It exists in nature. It's a whole number. It's an integer. And it's rational. Okay, 3/10, 0.3. I think that's just going to be rational. It's a pretty decimal. and it isn't one of these ugly dudes. So it's basically just a pretty decimal. Same thing here. Negative 0.45, you're just rational. Okay, I could write you as a nice fraction, but I'm not gonna. Now, I think square root of 12 is not pretty. So let's take a look here. Oops, go away. Yeah, ew, gross. Nope, I'm good. You're irrational. There you go. Flavors of numbers. Not going to spend a ton of time on that stuff because honestly, nobody really uses these type of, hey, what's the rational? It's just a thing that we don't use a lot in real life, and I'm all about real life applications. So understand the different flavors. Okay, use that kind of cheat sheet reference. Okay, can be nice decimals. Okay, which means they could turn into nice fractions, somewhat nice fractions. Think temperature numbers, positive, negative, but no decimals allowed. The weatherman never uses decimals. Okay, I don't think so. Whole numbers, that's when we're talking about people or whole things. And then again, animals can't think of the number 0. That's the only way I can really describe it, the difference between these lists. Okay, and then again, irrational means they ugly. They ain't going to be pretty when you put them in your calculator. So, and we already did those. All right, that's problem number 3.